Today's session is Profiling and Optimizing in Fiery proServer and Fiery XF. It is my pleasure to introduce our speakers for today, Carrie Maloney, Product Marketing Manager for Fiery Wide Format, and John Nate, Educational Architect and Trainer for Fiery Wide Format. So with that, I think we're ready to start. Carrie, please take it away.
Thank you, Yael. So today we're going through the steps and best practices to create and optimize ICC color profiles. As most of our audience will know, not using a suitable profile will compromise color accuracy, meaning both spot and process colors might not appear as expected. Custom ICC profiles are the best way to achieve color accuracy, resulting in greater satisfaction for your customers, less trial and error color, less reprints, and therefore less waste. Profile creation is the step after linearization, and for those who joined us last month, they'll recall, although we passed on a lot of detailed information, linearization really can be done in just a few easy steps, so it's well worth the extra effort to get the best results on behalf of your customers, as is custom profile creation and the extra step of optimization to get the very closest match as possible. So before we begin, we'd like to gather some information on if and how you create your custom profiles today. So we're going to take a quick poll. You'll now see two questions on your screen. You can select all that apply for both questions, and I'll give you a moment to complete those. Okay, I'll leave the poll open for a short while longer, so thanks for those who took the time to complete the poll. We'll share the results during today's session, and I'll now hand you over to John for profiling and optimization in Fiery proServer and Fiery XF.
Thank you very much, Carrie. Thanks, y'all, and thanks everyone for joining us on our last wide format webinar for the year. Glad that you were able to attend. Our goal is that after you attend this webinar, you're going to be able to understand, well, a couple things. How custom ICC profiles can really help improve the color output that you create, and understand how you would go about creating ICC profiles for your system using the Fiery XF, Fiery proServer software. One of the most important parts of creating an ICC profile is the configuration of the black generation settings. We've really got two different methods of doing black generation, kind of the old traditional way that we've done for years, and a newer way for the EFI printers and for newer printers that are coming from the other manufacturers. So we're going to cover both of those variations today. Also, optimizing color output. We want you to see, well, understand what optimization is and how it can benefit you and how it would be done. And finally, an often asked question is, how often do I have to do this? How often should I profile? How often should I optimize? So I will be covering that also. But first, we want to look at the tools that are available. What do we have available for building the custom ICC profiles? Well, the EFI solution is EFI Color Profiler option. This is an optional piece of software that is included in many of the proServers. It can be added to any system with the correct license, and it allows you to create ICC profiles, evaluate, and edit ICC profiles. Today, we're going to talk about creating ICC profiles. I talked about evaluating and editing in a prior webinar, and we'll have links to those after today's presentation, so you can go back and watch those if you're interested in those two areas. But specifically, creating ICC media profiles is what we're going to be talking about today. Now, the Color Profiler option is essentially the same software as the Fiery Color Profiler suite. The Fiery Color Profiler suite was designed for the toner-based systems, and over the years we have added features in order for it to build good profiles for our inkjet printers. You will see, especially in the traditional way of building profiles, that there is a little overlap. There are some bits and pieces that are really only for the toner system. We have changed that in the new version of the software, but we will take a look at both. They're, as I said, the same engine. They build the same profile. You can use the standalone Color Profiler suite if you have it. The benefit of using the Color Profiler option is ease of use. It takes you right through once you finish building the calibration file. If it detects that you have the Color Profiler option, the system will say, do you want to build a profile? You say, yes, I do. And it just goes right in and takes you along for the ride. When it's finished, it puts all the bits and pieces where they belong in the proper folder structure within FireEXF or Fiery proServer, which again saves that step if you need to do that manually if you use the non-integrated version or a third-party package for building profiles. Now, if you take a look at the color options, if you click on the little Color Tools icon in the top left area of the FireEXF or proServer interface, looks like a little colored pie chart here, you would launch either the basic color tool set. This is what everyone always gets, but there's no capability of building profiles. Notice, nothing here for building profiles. If you add the Color Profiler option, then this is the list you get, and these are the additional features. Creating the media profile, which we're going to talk about today. Creating a profile for measurement allows you to actually open up an existing profile and change some of these black generation settings and try different options. Device links, reference profiles, and monitor profiles can also be built, and as I said, the edit and inspect profiles, which were covered in a previous session. So why create custom profiles in the first place? Why does this matter? Well, first of all, profiling is passive. Profiling does not change the device. A lot of people think, oh, yeah, I had to profile my output device for Grackle or for ISO coded or something. Not true. You calibrate the output device for the best quality and then use ICC profiles to limit the output to try to get a color match to something, a different standard. I'll cover that in just a little bit. It was designed by a group of industry representatives, Heidelberg, Kodak, EFI, a number of us sit on the ICC committee. And the ICC Color Consortium decides what these profiles mean, how they're built, etc. But as I said, a profile it's a snapshot of the device's characteristics. It doesn't change the device. Imagine you walked outside with a camera and took a picture of a tree. Did the tree change? No, it didn't. But you now have a photograph that shows the characteristics of that tree right now. Does it have leaves? Does it not have leaves? What are the color of the leaves, etc.? Well, that's what a profile does. It captures the characteristics of your output device. A friend of mine, Steve Upton from Chromix, came up with this idea of color management is like making toast, and this is the area of color profiling. Okay, imagine you have a toaster, and I have a toaster, and we each toast 10 slices of bread, 1 through 10. Well, notice they don't match. But if you took the 10 slices of bread and measured them and put the density measurements into a file, and I did the same thing, we could then compare the two files and come up with, well, where does our toast match? Where is the common area of toast density? Also, what areas can't we hit? Can't we match? They're outside, we'll say, they're outside the gamut of the toaster. Well, this is what profiles do. We need two profiles that we can compare, and now, if we could somehow link our two toasters together, if I said, hey, I want to use setting 3 from my toaster, the results of setting 3, your toaster would automatically set itself to 5, and I would get a slice of toast that matches my desired results. And this is what ICC profiling does. It's the characteristics of the device, and then it's used with a second profile to match the output. And this all works fine until one of us decides to switch to, say, whole wheat bread. Well, now our density won't match. So we'll have to re-toast and remeasure all those slices of toast. That's no different than you've changed the media on your output device. You change the media, change the ink, there's a good chance you might have to reprofile. You may even have to relinearize, build a new calibration file. And I said we always use profiles in pairs, so take a look at this example. I've got my brand new 8-color printing press here. Just got it in, haven't unboxed it yet, but it's supposed to be super cool. And I'm going to print this poster. This poster is going to be printed to one of these specifications. Let's say it's ISO coded or FOGRA 51 or Grackle. but I print that to a certain specification. Now, I have an ICC profile from these various organizations that represent what that output will look like if that press is run to the settings needed to hit the correct specification. Okay, now I want to print the same poster on my inkjet printer. I don't care whether it's a tiny little guy or one of the great big 5-meter wide Vutex. Don't care. But I need the output to look the same. So I need to build an ICC profile of my printer so that the Fiery XF system knows how my printer can reproduce color. And then I use my media profile along with the reference profile to simulate the press output on my inkjet printer. So we always need these profiles to be in pairs. What can my machine give me? What do I want my machine to look like? A little more detail on how that works. Let's take one little patch. I've got a red patch here. Here is the specification, 100% magenta, 66% yellow. That equates to a particular LAB value. LAB means what does the color look like, also covered in one of the previous sessions last year. But this LAB value will be different depending upon what reference profile is being used. So let's say this is the reference value out of Foger 52. Okay, that's the LAB value. Well, I want to print this apple, which has a pixel that is that color, on each of these 3 output devices. Now, we could say there are 3 different output devices, or it's the same output device with 3 different media sets. Don't care. There are 3 different combinations of printer, ink, and media. I need an ICC profile that understands how each printer reproduces color so that when I send this LAB value to each printer through its corresponding profile, the system will come up with the right recipe. Notice they're all different, so that that pixel will look correct when output from each of the devices. So that is profiling, and that's what's important. It takes into consideration your ink, your media, your printjet, inkjet heads, the length of time it's been in use, all those different things. Okay. Now, if you have any questions today, please use the Q&A window, the question and answer window. We will try to get to as many of them at the end as we can. And, of course, we always send out the written questions and answers to all attendees. Carrie, do we have the poll results?
We do, John. You should now see them on screen.
Okay, so we've got pretty much equal amount of people that don't currently create profiles, use the Fiery Color Profiler option, the Color Profiler Suite, or a third-party package, and then, the majority want to keep it a secret. Okay. The ES2000, not surprising, one of the more common devices out there and one of the most popular, and again, even more people want to keep it secret. So it's okay, we wouldn't tell anybody, but good information. So a lot of you are doing profiling now. Some of you are not. So especially for the people that maybe are not or didn't want to answer, let's continue on and see how this is all done. How exactly do we build these custom ICC profiles? We're going to assume that we are continuing on directly after the steps that were covered in the last webinar on building calibration files, building the linearization, the .epl file. If that's correct, and if you have the integrated color profiler option on your system, you would get a little pop-up window that would say, do you want to build an ICC media profile? And if you hit next, you would see this window. Okay? It starts by automatically selecting the same measurement device you used to build the calibration file. The system assumes, and likely correctly, that you're not switching devices between the calibration file and the media profile, and I would recommend you don't switch devices in between. Next, you need to select the patch layout. Now, this is the set of patches that are going to be printed to your output device that we're going to measure. And then we'll build an ICC profile, which is the recipe for each patch combined with or linked to the LAB value. What does it look like? That's how the system knows how your device reproduces color. We have patch sets down as low as 46 patches and all the way up to 4,000 patches. I'm going to cover these in just a moment, so just kind of keep this list in mind. But the last item on this list is the media size. It will default to the size that is set up in your workflow. Fiery XF, even if you have large media, is going to make sure that the target will be printed that will fit either into one of the automatic measurement devices, or if you're using a device such as the ES2000, fit on the little support sled that comes with that you use the ruler for. So it won't make targets too large. However, if you are printing on very narrow media, then you do want to say that it is the narrower media. Let's say it's only 10-inch wide roll of media. Then you want to say 10-inch wide to make sure it doesn't make patches that are too big for the media. It will never make a patch target printed size that's too large for the measurement device. All right, so we've got the media size selected. We've got our measurement device. Let's take a look at that patch selection list that we have. The most common selection for proofing is the IT874 1617 patches. You go to many shops where they're doing proofing, and boy, that is the go-to target. It has served us well for many, many years. Now in production printing, well, we're not trying to normally measure a color bar to get a pass-fail, although that is starting to become a request from more and more customers. But if you're just looking for good, pleasing color, nice and accurate, 928 patches will save you a little bit of time, especially if you're using one of those handheld devices. Also useful for production printing, however, is the 234 patch target. To be honest, I even have some proofing customers that are using the 234 patch target. Makes some people a little nervous, okay? They want all the information in that 1617 patch target, but the 234 patch target is very, very good if you're just looking for pleasing color, and it's a very, very fast way to get up and running. The 46 patch target is good for a quick check. It's two little strips to measure. You can build a profile. Some people like it. Some people have seen some artifacts, especially in saturated colors. So I'd be very cautious to use that in production printing. But if you want to check and see, hey, is this EPL behaving, pretty good? Does it look like we're going to be fine? The 46 patch target, real quick way to build an ICC profile. 4028, well, that's if you just have too much free time on your hands. It was designed for the toner side for, well, printers that are very uneven, non-linear. Because we do our linearization and because of the nature of our inkjet printers, normally not an issue. So for most of you, if you're doing proofing, you're likely going to use the 1617 patch target, and for production printing, the 928 or the 234. However, you may need to go to the 1617 if your customers are starting to ask for validation of accuracy. You may want that little extra accuracy that target gives you. Once you've selected your target, the media size, and the device, and click Next, you print the target and measure the target. Once it's measured, then we have to set the default profile settings. Now first we have this little drop-down, and the drop-down will give you options such as traditional toner device, traditional inkjet device. There are even some printers listed, some Butech printers, etc. All that does is it sets the black generation settings. So there's no harm in setting something there because you can always go into Edit the Black Generation settings and change it. Next down is the Gamut mapping area. For most users, you leave those as the defaults. The only option you might want to consider is the following. You might want to change the Perceptual mapping option. We have an option that will increase shadow detail if you go into that option. In Fiery XF and Fiery proServer, you can select different rendering intents, different profiles, but you can't select black point compensation, which enhances shadows, if you select the perceptual rendering intent. However, you could come in here and select additional shadow detail in the perceptual mapping. That kind of builds in some black point compensation into the profile. Okay? I would never use that if I was doing proofing. Okay? You never want to have enhanced shadow detail on your proof and then they can't hit it on press. So this would only be for production printing and only if you want a little better shadow detail and you know you're going to use the perceptual rendering intent. If you're using colorimetric, you can select black point compensation so it's not an issue. Now let's look at the black generation settings. Okay, this area right here. If you click that button, you go in and edit the settings. And we're going to start by talking about traditional black controls. These are controls for our Epsons, our HPs, our Mamakis, our Mutos, our Canons, even the Butech printers if you're using an older version of Fiery XF. We changed the black controls in version 6.3. But let's look at the traditional controls first. We have a number of areas where you'll likely not make any change. Maximum black ink, maximum total ink. Well, we set that when we build our calibration file, so we really don't need to modify those. Increase black and shadows, maximum CMYK density ratio, and black amount to extend gamut. Those were designed for the toner side of the world. They find it very useful because of how the toner devices reproduce color. We will not need to use those on our inkjet printers. We're going to take a look at the rest of the areas. Now, first is black start. This will affect ink usage a little bit. And what it does is it sets where do we start bringing black ink into our output device. Right now I have it set at 20%. That means if I have below 20% density, just kind of simplify it, below 20% density on my output print, then I'm not going to have any black ink there. It keeps those little tiny dots of black ink out of highlights because it can make them look kind of grainy, kind of like sandpaper. If you have normal black ink only, you're going to want to set this higher. I've seen it set as high as 50 or 60%. If you have light black ink, and in some printers like from Epson, light black ink, you could even move this down to 0 and bring in black right away because you're not going to notice those tiny black dots because they're going to be very tiny gray dots, much less noticeable. You always have to take all of this with a rule of thumb. Always the answer for all the questions is, well, that depends. Now I said you're going to want to start black much later if you have only normal black ink because you don't want those little black dots in your highlights. But what if you're printing billboards or huge banners that are going to be on the sides of buildings? Well, nobody's going to see that little dot of ink in your highlight. Nobody's going to be driving along the highway at 100 kilometers an hour, see your billboard, stop, run across the fields with a loop, and take a look at the highlights. It's not going to happen. So you could start black earlier. What's that going to do? It's going to cut your ink usage a little bit. Okay? So the more this setting is to the left, a lower value, the more black ink you will use and the less CMY ink. Next up is black generation. Black generation is what we used to call GCR. Well, actually still do call GCR, but we call it black generation. Here's how that works. Imagine we have a pixel. This is a red pixel. It's made up of a bunch of magenta and yellow, but there is some cyan because there's often that third color, the tertiary, some call it, the contaminant color. Whenever you separate files through ICC profiles, which we all do, then you always get this unwanted contaminant color. And if you look, this is all really combined to make neutral density, gray. This is the gray component of this particular pixel. Well, I could replace that with black. Gray component replacement. I replace it with black. I can use an amount of black and I can reduce the magenta and yellow, take that gray component out of there. If I stack these up, you'll see I'm actually now using less ink. However, the colors should match. That's the key. It only does this to the limitation of being able to reproduce the color accurately. Okay? So there's a limiting factor there. Make sure the color looks correct. Now this is where you can save a lot of ink. And again, the farther to the right, the more aggressive is going to be your ink savings. The farther to the left, you're going to do very, very little GCR, very little black generation. We've got one final option that goes hand in hand with black generation, that's black width, where in 3D color space, again referring back to one of the earlier sessions on fundamentals of color, where in this color space am I going to apply my black generation? If black width is set very, very down, very, very low, down to 1 or 2, you're only going to be dealing with the gray axis. Only pixels that are neutral will have black generation applied to them. If you move it all the way to the right, it will be every color of the rainbow. Don't care what color it is. If there's some black generation that can be taken care of, do that. And then it applies however much black generation you select. So those two go hand in hand, and those are the main ink savings features or options for building an ICC profile. Now going back, once you finish, to the main panel, we also have a maximum GCR option right below the Edit Black Controls. If you check that, it will move those two settings, the black generation and black width, almost all the way to 100. Not quite, but almost all the way. If you have experience and you know that's what you want to do, by all means, you can just check that box. I don't recommend making any change until you test with the defaults, however. It's kind of one of the keys to color management. Come up with the defaults, make a print, and that's your golden stick in the ground. That's your target, your anchor point. Then come in and make some changes and reprint and see, do you like the results better? Or if you measure, are they more accurate? Okay? And the key is, don't make a lot of changes at once. Okay? We go back to this panel. Don't move black generation all the way to 100, bring black start all the way down and black width all the way up. You make another print, you don't like it. Well, which one of these three options that you changed gave you those results? Well, you may not know. So please only change one at a time. However, if you do select one to change, make it a change big enough to see a difference. If you take black generation and move it from 50 to 51, well, that's not going to do anything. You're not going. I mean, it will, but nothing you're going to see, and you're likely not even going to be able to measure that. You have to make a substantial move. Maybe move 50 to 60 or 75, somewhere in there. Okay? Then retest. So only move one at a time, but move it a fair amount that you're going to be able to detect a difference. Okay. As I said, you could set maximum GCR. We also have an option to optimize colorimetric precision. This increases the accuracy of the profile transform a little bit. I do recommend turning it on and just leaving it on. It's recommended for proofing, but there's no reason not to have it on for production. It takes a little longer to build the profile, but it won't take any longer to actually do your work. It doesn't slow down the rips. So, hey, if it increases accuracy, why not turn it on and leave it on? Our last option is the viewing conditions. Here we can select a different lighting condition for the final output. Now this again is really for the toner side of the world because we have the same exact feature within the Fiery XF and Fiery proServer interface on the color management panel. You can select a different lighting condition and Fiery XF will automatically counter the lighting conditions by making the proof or print the opposite color, okay, so that it looks correct under those lighting conditions. Well, again, since we can do it within the Fiery XF and Fiery proServer interface, I recommend leaving this at D50. Leave your ICC profiles alone, okay? Make the changes within the interface. Once those settings are done, you click Next, you save the profile. Now, here is the key to having the integrated version of Fiery XF, or I should say the final key to having the integrated version of Fiery Profiler in the color or the Fiery XF or Fiery proServer interface, and that is it will automatically be linked to your calibration file and automatically moved to the correct folder. If this doesn't happen and you build the profile, you still can't use it. So it's a very important step, and the software does it automatically. All right, now that was the traditional way of handling black generation and building the profile. New in 6.3, we've got new black controls for the EFI printers, the Viewtech, Matana, Reggiani, also for a couple of additional printers from other manufacturers. So Viewtech, Matana, Reggiani, the Epson SureColor P7000 and 9000, and the Mamaki TS300P-1800, wish they'd have a little longer names for their printers. You're going to see this new version of black generation settings available for more and more printers as we go along. So if you don't have one of these printers on the list, still pay attention to the next area on black generation because it's likely in the future these will become your options. All right, printing, measuring, no difference, same targets, same patch choices. Really it comes down to the black settings that is different. And the black settings, we start by setting our traditional settings again. That's the starting point for black generation. And you can edit the black controls and override that, or you can just simply go into edit the black controls and put in exactly what you need. Let's take a look now at the new black controls. You'll see the interface is a little different. We've now broken it up into 4 tabs. Also, there are no toner-based options in the interface anymore. These are all inkjet options. On the black controls panel, they're the same 4 that we looked at in our traditional black generation set of controls. Maximum black ink, set by the linearization file. Black start, depends upon whether you have light black or not, how much black generation, and how aggressive do you want to be. Where do you want to, or how aggressive do you want to be, and where do you want to apply it? So no different there, the same controls. Things change when we look at the advanced black controls. We're now giving you additional control over ink usage. And it starts with ink amounts of black. That's this area right down here. How much ink do I want to make my black? How much cyan, magenta, and yellow? The amount of black will be controlled by the ICC profile itself. So why do we have black ink? Well, we have black ink because we need to make good shadows, and CMY don't make good shadows. Now, shadows are traditionally made of a rich black. We add cyan, magenta, and yellow to that black to get additional density. But maybe we don't need that much density. If you notice, maybe you've got ink piling at that deepest area, maybe some modeling, but just too much ink. Well, we can now give you the option to reduce cyan, magenta, and yellow separately to pull some ink out of there. That can also maybe give you a little better shadow detail. Okay? But be careful, you could actually cause what we call tone inversion here, where you pulled so much colored ink out that the darkest area of your shadows start to become lighter than a lighter area of your shadows. Imagine a photograph of a car tire. The deep down area inside the treads of the tire, that jet black, no detail, you could actually make those a little lighter than the surrounding area, and it would just look wrong. So use a little bit of caution here. Again, start with the defaults, test, then come in and make maybe one change at a time, or maybe you come in here and bring these all back, maybe 5%, 10%, and retest. So that ink amounted black. Black usage at Gamut surface is the side area here. It starts from the saturated areas going down into the shadow areas. Here, where do I want to bring in black? How high up on this curve do I want to start bringing in black ink? Okay? If I bring it down, I will start using more cyan, magenta, and yellow ink in those areas to try to keep those tones. If I bring them down too far, I could actually lose gamut in these areas, so that's the danger. We often are starting with a decreased amount of yellow and black back in this area. Again, small black dots of ink in saturated yellow are easier to see than in other areas, easier to detect. So we bring it down a little bit. That will increase your ink usage a little bit in those areas, but saturated yellows will look nicer. That's what all this is. It's a balancing act between how does it look and how much ink am I using. That's all this is. Chroma. Now, the next few options are only valid if you use the perceptual rendering intent in your Fiery XF, Fiery proServer workflow. Starting with chroma, this is the saturation, and it's a boost of either none or 10 or 20 delta C units, delta chroma. Imagine you've got the slider in Photoshop, and you're moving the slider in Photoshop to the right. It moves all the colors out towards the outside of color space. That's where our saturated area is. It's really what that option does, but we're now building it into the profile itself. Next is lightness. So this is globally affecting the lightness. Now here, plus or minus, I could move the lightness slider in Photoshop to the right or left, making colors lighter, moving them up towards the top of color space, or darker. No difference here. I can make overall lighter or darker. Think of what we're doing here. We're looking now for pleasing color. You would never use these for a proofing situation, okay, because proofing rips don't normally have these options. So this is for production printing. Hey, you know, overall I like the output from this particular printer with this media. Just wish it were a little lighter or a little contrastier or a little less contrasty. Same thing, we will apply this S-shaped curve for additional or less contrast. Finally, we have shadow lightness. This will raise the darkest areas of your image in the ICC profile to 4 or 6 L-star values. Now, 6 L-star values, which is the light and shadows high setting, may not sound like much, but what it's doing is it's taking all these areas down here and raising them up. And although you likely won't get a tone inversion, what you may do is start to get washed out shadows, maybe shadows that you don't like. So again, test. Make sure you select a setting and test with enough valid images that you can detect what's going to happen on the output. Our last tab is the processing tab, and we start with input data smoothing, least to most. What this does is it will modify the measurement values that come in from the spectrophotometer. Okay? The measurement values come in from the spectrophotometer, and there might be noise in the system. Well, what's noise? How do I know that? Well, take a look at the patches that you print. Are they nice and even? Are they smooth? Do you maybe see some variation? Print a large area of gray across the entire bed of the inkjet printer. Do you detect some modeling? Well, when you measure it, that's going to come in as noise. And you may want to move this slider to the right to start to even out, take some of those artifacts out. Now, technically, you're going to have less accuracy because you're changing the values of what was measured by the spectrophotometer. Again, it's the balancing act between accuracy and looks. It might give you smoother color outputs, especially in gradients, if you smooth the input data before you build the profile. Table smoothing will be used if you detect in gradients problems like this, where they're just not smooth. You get maybe some banding, some weird artifacts. You may want to try the table smoothing. Now, the two kind of go hand in hand. It might be input data that needs to be smooth. It might be the table that needs to be smooth. So you might want to try one, build the profile, then zero that out, try the other. And again, here it's perceptual or colorimetric. Here it's for both. But try them both and see which one gives you the best output. Again, table smoothing or data smoothing will lower your accuracy a little bit. So use it with caution, especially if you're doing verification of output. Finally, we have table size. Table size directly affects the quality or the accuracy of the ICC profile. Moving these sliders to the right builds in more data points, more anchor points inside the ICC profile. And technically that will give you an increased accuracy. The defaults here often will work fine for most people. Be careful. If you move them all the way to the right saying, I want the most quality possible, you're really going to slow down the rip. I did a test where I printed a file, and it took about, a minute and a half, 2 minutes to do the color conversion before I printed it on the output device. I moved the corresponding sliders all the way to the right. It took over 45 minutes to do the same output. Okay? If you move them all the way to the left, you're going to ultimately turn off color management. You'll wind up with grayscale images. Okay, so not necessarily a way to build a grayscale profile, although I have to do some testing and see if actually that might not be a bad thing to do. But for most people, you're not going to do that. This directly affects the time it takes for your RIP to convert files. So moving them to the left, faster. Moving them to the right, slower, but increased accuracy. Those are the various settings now for black generation for the newer versions of our software with the EFI printers and more new printers coming from other manufacturers. Okay? So if you don't have one yet, but you do get one in the future, again, we'll have this recording available, and you can always refer back to this to find out what these settings are if you forget by the time you get the printer. Okay? All right, well, I built a great calibration file. I followed those directions in the video last time, and now I built a good ICC profile. What is this optimization? Optimization, people talk about optimization. Well, why do I want to do optimization? Well, you want to do optimization to improve the color accuracy. Well, why? I was very careful when I printed and when I measured and tried to make a good profile and a good calibration file. Why do I need optimization? Well, our devices and math are not perfect. Devices are different manufacturers, older devices, newer devices. Everybody's got their special sauce that they use inside for how they do the measurements and different optics and different lighting systems, etc. So those are going to be slightly different. Also, these devices give us what are called spectral values. It's numbers like this. This is actually the number set for one color patch. Ultimately, it becomes one LAB value, and maybe not even to 2 points past the decimal point, maybe even just whole numbers, whole integers. Well, all of that is going to decrease the accuracy. So for that and other various reasons, color optimization is often important, especially in the proofing area. So how does it work? Well, it works by printing a color management target and analyzing it and comparing it back to the reference profile. Let's, for example, take this one cyan patch. Let's say I printed it. In my workflow, I've got my workflow set up for Folger 51. Folger 51 says that CMYK patch, that recipe, should look like this LAB value. But when I printed it on my ViewTech and measured it, I got this LAB value. You can see they don't match. So what the optimization process will do is it'll come up with a correction factor. It'll say, hey, when you see this LAB value come out of this ICC profile, raise the L star, or lower the L star value 2, leave the A alone, and raise the B star value 3. And come up with this recipe, send that to the printer, so that when the printer prints it, it actually prints this value when measured with a spectrophotometer, and now they match. The optimization process will create this correction factor for every single patch you measure when you do the optimization. And it will put them all into a .3cc file, a 3-channel color correction file that is loaded on the color management panel under the LAB correction drop-down window. So how exactly do we do it? Well, it's available with the basic color tools or the color profiler options. Everybody always gets to optimize profiles, whether they're profiles that we built or the standalone or profiles from another package. You start by loading the workflow, selecting the workflow. The system will then load all the bits and pieces. You select the measurement device. You select which chart you want to use. Now, it's very common to use a smaller chart for optimization. We used to think, well, you have to use the same chart for profiling and optimization. Not true, and you will actually possibly get a little better gradient smoothing by using an optimization target with fewer patches. Okay? But you're free to use any of them. If you want to stick with the 1617 or the 928, the same patch set you used to build the profile, by all means do. But hey, give the 234 patch test run. See if you like it. It's going to be faster, especially if you use a handheld device. Optimization method. If you have an optimization file already in the workflow, FireEXF will defer to optimize existing LAB correction file. It's kind of picking it up where it left off and just nudging it in the right direction. If you don't have one already selected in the workflow, create a new one will be by default. Optimized media profile, kind of a specialty area. We're going to cover this next year in one of the first webinars on process control likely. So make sure you come back next year for the next series of webinars. But likely you're going to do either create a new one or optimize the existing. Finally, we've got the white point settings. The default is absolute colorimetric, which means we're going to simulate the white point. If you don't want to simulate the white point, you can select suppress paper white. Don't be surprised, however, when the first printout is printed absolute colorimetric. You do get the white point simulation. The optimization feature needs to understand what white point simulation should it be using in order to figure out when it removes it how to accurately render highlights. So the first printout is absolute colorimetric, the rest will be relative. If you've edited the white point to match your output, it's a common edit people make to their ICC profiles. They're doing absolute colorimetric printing, but the white point was a little bit off, and that's to edit the ICC profile. If you've done that, if you select Keep Current Paper White, the optimization process will change everything else except the white point. You click Next, you print, measure, Next, and you will start to get delta E values. We'll cover these in detail in a bit. On the right, it'll show you an arrow, and the arrow will point up if it feels there's improvement to be made, down if it feels there's not improvement to be made. However, you can keep going. You decide when to stop. Okay? The recommendation is 3 or 4 what we call iterations. Iteration is print, measure, next after the first one. So the first one shows you where you're starting from. The second print is your first iteration. So 3, 4 maximum usually is the most anybody needs to do. So what are we looking for here? Well, we're looking at the delta E values. We've got average, peak, paper white, and target in Gamut. We want the average delta E, if possible, to be below 1. That's the threshold where a trained eye can see the difference between colors. So that means on average, we're a good match. Peak delta E, we like below 5, but gosh, it depends upon the media. Sometimes, especially in the production arena, we don't have a choice on the specific media that the customer wants, and well, we just can't. Maybe it's the white point is way off, or different reasons that we just can't hit those. So that's going to be very much dependent upon the media. The paper white also we'd like below 1, but as I said, that very much depends upon the delta E, or the media itself, and whether you're optimizing absolute or relative colorimetric. Total amount in gamut, that means how much of my reference gamut, swap or ISO-coded, is within the gamut of my output device. If you're doing proofing and going to do verification, I want to see that number above 98, or you're going to have a lot of trouble trying to get a proof that matches to one of the specifications. For production, once again, depends upon the media. So just kind of some guidelines here to use. Now, how often? Very, very common question. How often do I need to do this? For profiling, if you get a new media type or a new ink type, you're likely going to need to build a new profile. Often you will likely also need to build a new linearization file and a new ICC profile. I always say the worst day in my life was the day that I got a new package of Inker media that came in with this big sticker that said new and improved. I just knew my day was ruined because now nothing would match, and I would have to likely start over with a new calibration file and a new profile. Again, aqueous inkjet printers are much more impacted by a change in media. UV inkjet printers, not so much. So again, you want to test and find out if you do need to or not. Well, how about optimization? Two ways, a visual change. Now this can also be used for whether you need to do a new profile. When you're finished and your system is set up and running well, and you're happy with it, print a set of sample images. And you want some various skin tones and some saturated colors and some pastel colors and some neutrals. You want all those in that test. Don't just print a picture like the upper right-hand corner with just what I call circus colors, just bright saturated colors that my grandmother could hit on a bad day. Okay, you want a large variety of colors. Print that, store it in a cool, dry place, out of the light. Bring it out a week or two later, reprint, and compare the two under your lighting conditions. Do they match to within your accepted level of accuracy? If they do, put it away again, try again in a week or two. You might want to just re-optimize every month or so, even if the visual output looks accurate, looks acceptable, because you want to use optimization as preventative medicine, not, oh, break fix. We can't send anything out. We've got to optimize to bring things back into compliance. Now, a better way would be to use Color Verifier and measure a color bar on your output and see whether you pass, whether you're in compliance. And if those numbers start to get high, right here you can see it's not okay in a number of these. My system's broken. I need to optimize in order to get it back into compliance before I can ship proofs. Well, as these numbers start to creep up, that's when you want to take corrective action. If this is getting close to maybe 2.8, certainly 2.9, where 3 means it's no good, that's when you want to re-optimize. So to summarize, today we learned which targets to use for profiling and which to use for optimization and why. The impact of the black control is very, very important when you're setting up your ICC profile to use the correct black control settings. But again, where do you start? The defaults. Use the defaults, make a test print, then you can open up, you can use the option to create a profile from a measurement, open up that profile, make some changes to it, try that profile, try different variations, and see what works the best for you for how it looks versus how much ink you're using. And finally, we learned how often to re-optimize and reprofile. So hopefully this is all very good, useful information for you, and you'll be off this afternoon building some nice, accurate custom profiles for your system. If you would like to learn more, we have some more resources for you. Carrie, back to you.
Thank you, John. Yes, we do have some resources for you. We have X-Write's Complete Guide to Color Management, and that's for a ground-up overview on this topic. We also have 2 linearization and profiling guides, which some of you may have seen before, one for non-EFI printers and one for EFI printers, both of which are available on help.efi.com. And as always, the presentation PDF that we send to you after the session contains live links to any locations that we've mentioned. Also, not to forget about the existing World of Fiery wide format session recordings from this year and from last year as additional learning opportunities. So today's profiling and optimization session, as mentioned, is our last wide format session for 2016. However, we do have a follow-on session planned for early 2017 on color process control and verification. So watch out for your invitation or keep your eye on the EFI webinars calendar for that particular event. Also, it's still not too late to tell us what you'd like to see in the webinars calendar for next year. So you can complete the short Have Your Say form and let us know your thoughts on that.
All right, so great session. We have some questions coming in. For those of you in the audience who haven't, please do submit your questions via the Q&A or chat windows. We're going to try to get to as many as we can. So without further ado, Carrie, let's get going.
Okay. So, John, what is the difference between Color Profiler Option and Color Profiler Suite?
They both use exactly the same engine. So if you feed them the same information from the same target measured with the same spectrophotometer and then use the same settings inside, you will get the same exact results. The standalone Color Profiler Suite is primarily targeted toward the toner market. The benefit really of the integrated system is ease of use. It will allow you to go right from the building the linearization file directly into profiling, and it does automatically put the bits and pieces, link the profile to the calibration file, put them into the correct profiles folder, the media profiles folder, so they can be used. So it's really ease of use for the integrated version. You can make just as good a profile. You can make exactly the same profile on the standalone Color Profiler Suite, but you have to know a little more about what you're doing when you put things where they belong and get up and running and get started. So it makes printing the target easier, makes finishing and using it easier also.
Okay, next question is, why are linearization and profile creation two separate controls?
They really perform two different tasks. The linearization changes your output device. It says, well, how much ink is too much ink? And there I don't mean it's costing me money. I mean it's too much ink because I'm getting problems. On my aqueous inkjet printer, cyan is coming out wet. Anything that's got cyan, it comes out wet. In my UV inkjet printer, I've got piling, I've got modeling, I've got really physical problems with it. And we also want to have a linear state. That's why we call it the linearization file, even though that's only one step. We want nice, even gradations. The ICC profile is built under those calibrated states. Now, imagine if you didn't calibrate the system first. Could you build a profile in the uncalibrated state? Sure could. But what happens if your printer is nonlinear and there's very, very little change, let's say, in the cyan ink from 0 up to 50%, but a huge change from 50 to 55%. It's incredibly difficult to color manage. You're trying to make a huge change in your highlights for very little difference, and suddenly in the midtones, there's a huge change. You're likely going to get banding, etc. So linear, they are both very, very important, very specific tasks. One sets the characteristics. The ICC profile then understands the characteristics so that it can communicate the correct recipes to the printer to get you the values you want, the look you want, based on the reference profile.
Okay, thank you, John. Next question, how can I get my Epson spectroproofer to scan the color chart as it prints?
As it prints?
Yes.
Well, as it prints, it can't. You have to wait until the entire target is printed. On the special tab of the output device selected, select the Epson, then go to the output device, and there you can select whether to use the, you can set their calibration times, etc., but you can select whether it's the or the ILS 20 or 30, the older one or the newer one, and which lighting conditions. When you build your calibration file or your linearization file, that's where you select to use that device. On the device drop-down list, you would select the Epson SpectraProofer, the ILS 20 or 30, for building either the calibration file or the profile. If you have a newer printer that has the ILS 30, that may not be an option in an older version of the Fiery XF software or the Fiery proServer. So you may need to upgrade to your system in order to be able to use the newer SpectraProofer.
Okay, next question. Where on the Gamut surface does ink at Gamut surface start?
Ink at Gamut surface really starts at the maximum cyan, magenta, and yellow primary and secondary red, green, blue areas, going down into shadows, where it starts to bring in additional ink to lower the L-star value, to make colors darker. That's where we would traditionally start bringing in black ink. Now, it's not necessarily exactly at the equator if we looked at 3D color space, because 3D color space is always shown as this perfect little globe. But it is in the areas of saturated color moving into shadow tones.
Okay, and a quick question on, is the 46 patch chart no longer available for Vutex print models?
It's up for debate right now. We haven't released 6.3 yet, or 6.4 yet, but it actually may be removed. The problem with it is it's a great thing for quick testing, and some people like to use it for other purposes, but other people were using it and are calling in going, well, I'm getting bad results, and we find out, well, you used the 46 patch target really in a printing situation that you shouldn't have. They're trying to do accurate proofing, and they use the 46 patch target, and they're measuring their color bar and not getting good pass-fail results. So there's a thought of removing it just because it's causing some of our, too many of our customers problems. But the jury's still out on whether it will be in 6.4 or not.
Okay, and can you repeat the bit about the perceptual black point, please?
The black point, if you use the perceptual rendering intent only, and you are selecting one of the options, let me go back to that. So we've got light and shadow, slight, medium, and high. Normal is no boosting in the L-star value at all. Slight, medium, and high is L-star value of 2, 4, or 6. So what that means is if I have an L-star value down here of, let's say, 8, and I use medium, it will become 12 L-star. So it will raise it that 4 points. And it keeps all the relationships proportional. So it doesn't just kind of hammer all these shadows. It does bring them up and then scales them into other darker areas of 3D color space. So you should not notice banding. You should notice an enhancement of shadow detail. But again, use caution, because depending upon what you're printing, you may wash out your shadows a little more than you want to.
All right, so we are at the top of the hour. I know we have more questions coming in, so let's take just a couple more here live, and then any questions we didn't get to, we apologize ahead. As I said at the top of the hour, we'll get back to you individually. We'll also compile an FAQ document that will have all questions and answers for our entire audience to take advantage of. So Carrie and John, let's take two more.
Okay.
Okay, so what are the best black control settings for proofs on an Epson 7890?
The best black generation settings, if we're looking at the traditional settings, I would expect there you're going to leave the black, maximum black, and maximum total ink up at the 100%, because those are controlled at the calibration file level. So you're going to leave maximum ink and maximum black ink at 100. Black start, again, if you're using, I'll be honest, I can't remember whether all these different printers have light black, light black, even on the Epson side. But if you have light black, then I would start down around 20, maybe a little lower. If you have light black ink, then you can bring the black start down. I've even brought it down to 0. I've got a 7900 in my testing lab, and I brought it down to 0, and I really can't detect the tiny little black light gray dots from a reasonable viewing distance, meaning a foot or so. Yes, if I get a loop out, I can see it. And then black generation and black width, I would tend to move those all the way up. If you set the maximum GCR, you'll see black generation, I think, goes to 99 and black width to 100. Not bad spots. That'll save you the most ink and probably give you very, very good results. And black amount to extend gamut, maximum density ratio, increase black and shadows, leave those alone. Leave those at the default settings.
Okay, and we have a question that we didn't get to on the last live session, which was on an LXR Pro 3250 will not allow re-optimization with Fiery XF. It tries to force us to start with the ink settings for profile creation.
I have not had a chance to test, but I'm told that that's fixed in 6.4. That relinearization is available on all Vutex in 6.4. There was some kind of a bug. We came out with 6.3.1. I don't remember whether there was a bug fix in that for Vutex printers or not, but that should be fixed in 6.4, due out soon.
Okay, we'll look into that one a little bit further and get back to that on that one specifically then. Okay.
If not, we'll yell at the development team to get it fixed.
Sounds like an idea.
All right. So unfortunately, as we usually do, we have questions that we aren't able to get to within the scope of our webinar, but we will get back to everybody and get you your questions answered. We want to thank our audience for joining us today. We look forward to many of you coming back in 2017 and joining us for those wonderful sessions that will get lined up and advertised very soon. Thank you, Carrie and John, for a wonderful session, and have everybody have a great rest of your day, and we'll see you soon. Thanks.
You are welcome, and again, thanks everybody for attending. See you next year.